was in charge of this card punch and used to cycle to the Department of Census and Statistics with a whole deck of cards behind me and a very large umbrella, just in case it rained. Computing has changed. I was there to support undergraduate teaching, and Professor Samaranayake returned, and he was appointed as the department head. And then Ian Wilson came from Reading also, and he supported the start of the MSc course, and then we had the link. It had started informally well before that, but this is what Ian, and I hope you'll excuse me that you may have to read some of this because I don't think I want to read it out, wrote about Professor Samaranayake. And I just want to, as you read it, I just want to pick up on this aspect that Sam worked in his own way, and his way was extremely effective. It wasn't conventional, and we learnt from it. Might give too many people ideas for the future. This isn't quite finished, but another aspect of Professor Samaranayake was that he was a university person, so he loved argument, and he didn't mind being criticized, and the logic of it, and he was a very straightforward person. And a number of you have also mentioned he was tremendous at multitasking. So I still have a very vivid memory of him sitting there in his office, and I brought along a visitor who was from another country. And what's his problem? I was giving him my full attention. And the amazing thing is, he was. He was also giving all the other people his full attention, but somehow he could do that. So if you wondered why so much happened, he was a tremendous multitasker in an amazing way. And the way his mind could switch between different topics was just fabulous. So we had the link, and we wrote up about the link, and it involved all the Reading department. And Robert Curnow, who was in one of the early pictures there, was if we had an equivalent to Sam, it was Professor Robert Curnow, who became a very eminent statistician, and he and all the department benefited tremendously. So I'm sorry you've got another little bit of reading, but there isn't much more after, because I asked him to say a little bit about the link, and this is what he writes. This also gives me the opportunity to follow Robert Curnow and mention myself, Dr. Savitri Abeysekera, who was another absolutely key person in our connection at this time. And that story continues a little bit because Ian Wilson followed me and set up the MSc. He was then with his wife Jennifer, and in 1985 they separated. And it's to my great pleasure that in 1990, Savitri, then in the UK, married Ian and is now Savitri Wilson. So our link certainly continues in one way, and I wonder whether it could continue in other ways. I would like to take a number of topics that we did in this link that I think are still around today, and then there's some questions in these. So one of them, the first is statistical games. The second, as you've heard, I'm very interested in climate. Improving the climate for statistics was intended to be partly the idea of what is climate, and that's because we do work on climate work. What about the consulting service and statistical software? So let me start with the games. The crop cutting survey is something that's happened in Sri Lanka since 1952. Rice is so important in Sri Lanka. And here's a graph of the crop cutting survey. And in about 1978, a lady called Anila Vijayasinghe came. She's now, I think, Anila Dias Bandaranayake. And she just came for a shorter visit, and one of her jobs was to see whether we could turn the crop cutting survey into a game. And we did, a statistical game, really a simulation. I should tell you one other small story about her, which she won't like, but I don't mind that. She arrived on her first morning she arrived maybe at 9 o'clock, and at 12 o'clock, the administrator of our department came to see me and said, this lady, Anila, is very charismatic, isn't she? And I said, yes, she's a very interesting lady. And she said, yes, you know, we have 4 secretaries in the department now. We had secretaries in those days, and they've all stopped all their other work, and they're all working for her. And she had that ability, and this is why she was very productive. So we invented a game, and this was a survey game. And we challenged students. At that stage, of course, we didn't have many computers. So the idea was that we would challenge students, usually working in pairs, to design their survey from the 160 farmers in these 10 villages. But the villages were a different size. So they first had to decide how many villages, then they decide how many fields and which field, and then what plots within the field to do their crop cutting. And choosing a plot, which you can picture, meant choosing an envelope in those days. And they chose the envelope, but they would interview the envelope. And when they interviewed the envelope on this one, this had a size of 1 acre. It had fertilizer of 200 weights per acre, and it was old improved rice. And then, from within the envelope, they could take 1 or 2 slips of paper to get the yield. They now had their data, which they had to enter into a spreadsheet or into a statistics package, and then they had to do the analysis. I do find one aspect of this interesting, that many statistics problems are multi-level. When I look at what's being promoted as data science, I don't see multi-level coming in very much. I think we're going back a step in some aspects. So we invented this game, and of course it was played with envelopes. Here you're looking at the survey, which is captured from the computer version of the game, which we made in the 1990s. However, we found that playing the game on the computer had a few problems. They didn't seem to get the hang of it as much as where you put these villages out on a large set of table and people could visualize the population and then the sample and then the data and the analysis from the beginning of the study to the end. Much better if they actually saw it physically. By the year about 2010, when we tried to use the computer version, the language had disappeared and we couldn't get it. And we still now find that the last time we used this was this time last year, and many students, 54 MSc students, found this highly novel and educational. So this is one of the things we started with 40 years ago. And here's some of the data from it. And we use this as an example to show simple data analysis. I just want to draw your attention to these villages. I don't know if any Sri Lankans here recognize these villages. They're rather unusual names for Sri Lanka villages. The first one is Sabi, which stands for Savitri Abeysekara. Then there's Kesson. Now you might get the idea of Kevin Senivaratna. Followed by the person who just proposed me, Nihal Kodikara. And then I felt it was wonderful that I'd been doing all this liaison with Nandasara, and there he is immortalized in our statistical game. Climate. As Professor Kodikara has said, we spent a long time analyzing climatic data. This was a long time before climate change became so important. And I do think there is continued scope for continuing these analyses. And so this is another of these areas that is in the past with our link that I think can continue. These data that we use are not used much by the National Met Services. They're all trained in physics and meteorology, not statistics. This was an era before the National Met Services guard their daily data as much as they do now. There are ways around that, which we need to find. But I think there's quite scope for coming there. And currently, the world over, because of climate change, there's tremendous emphasis on climate work, especially in agriculture for small-scale farmers. And I'm showing you here what it usually does. Most projects for small-scale farmers start by going to the meteorological department, and they say to them, we've got a big project, what can you do? They're all trained in physics and meteorology. So they say, we can improve our forecast, and we can also have a long-term forecast, a seasonal forecast, which is absolutely true. But what we did, because we've got the statistics, is we added a component long before the season where we analyze the long-term data. We don't have problems getting the data from the National Met Service because we ask them to do the analyses. We don't ask for their data. Who's going to give them the capacity building so they can do the analysis? Well, I think it should be the computing and statistics people within the university. And this is a project which is in many countries. I haven't seen it in Sri Lanka, but many countries in Africa and in the Caribbean is current now. And part of the interest in this, and this is an example from Western Kenya, is that many people are amazed that you don't need education to look at pictures and to count. So doing the analyses and working out the risks for themselves, here's a sample of African villages from the west of Kenya, most of the ladies having had zero education at all. And they have no problem with the calculations they're being asked to do. And being asked to do the calculation has brought the subject alive to them, and they very much enjoy this. My third subject is statistical consultancy. My belief, and I haven't changed, when I arrived in 1973, is if you're truly going to do applied statistics, you must apply the statistics yourself. Otherwise, you go into the more theory. And in Colombo, I took a list of the consultancy we gave. And this is a very small list. I've given a few more in the written version of the paper. But there's really quite a lot of impressive clients here. And this means you bring these topics back into your teaching. In Reading University, we didn't do it, but we did it slightly differently. We set up the Statistical Services Centre in 1983, which was 100% self-financing. But we were very keen on having a lot of consultancy work within the university for outside people as well. Now, what's the situation? Well, Colombo University, the statistics department, it's all part of the Colombo Science and Technology Cell, which has set itself up as a limited company based in the university. Perfect. It's working very well. And it's going to be a big success for another very special reason, because their office is exactly where I started work almost 45 years ago. It's in the statistical unit. So obviously, it's destined for success. In Reading, what we found is universities have become less conducive, so we moved out of the university, but we're continuing our consultancy work, and we're linking with a number of other universities now. Statistical software. I have a question, because I'm with lots and lots of computer people. I don't know another subject like this. Maybe you can say Fortran is still alive, but it's not as favored as it was before. SAS and SPSS, if you're interested in statistics, are the standard statistics packages that you would know about, particularly SPSS. And it started 50 years ago. It's the 50th anniversary of these statistics packages. Most software isn't like that. If I give you quickly an example, everybody now uses Excel, but they didn't always use Excel. Before Excel, there was Lotus, and everybody used Lotus. And before Lotus was VisiCalc. And we're still not back to the 80s. What are the other subjects? And I'm going to ask the other visitors to tell me the other domains where the standard software now is 50 years old. And that's very interesting, to my mind, in a number of ways, because if you take SPSS, every time there's a new invention in statistics, they add it. but they never subtract anything. That's incredibly confusing for students. So microcomputers came in the 1980s, and there were lots and lots of stats packages, including our little Instat, which, as you heard, was jointly developed by the computer people within our unit here and Reading. We then added climatic facilities. And I have to say, slightly sadly, that it's still used today. Very few of the packages in the 80s are used today. It's still used today because things like the start of the rains and dry spells aren't in any other or there isn't other good software for that. But it needs to change. And I'm doing a sidetrack now, which I can do very quickly, because as has been told, we actually contributed to the election, and I was there the first time this happened. And that continues still. And this is the message from the then Vice-Chancellor to Professor Samaranayake and the team. No, this was by the Commissioner of the Elections to the Vice-Chancellor. I will just tell you one story about that. When the Commissioner of Elections this first time round was using Professor Samaranayake's computing, he was extremely suspicious. He felt that this newfangled idea wasn't going to work. I have to say, if he'd known about our standard of programming, he wouldn't have let us in the building, never mind be suspicious. And we were very lucky. But it did work. In the end, he felt his team down in the basement were going to be very slow, but at least they would not make mistakes. Luckily for us, he didn't see the mistakes we made, but there were 4 discrepancies between the computer results and his team. They were only small, but they were all his team. So by the end, he was more convinced, but not very convinced. When the last district had been announced, we immediately had the results. Of course, we were using a computer. His team down in the basement had to add up again for all the districts. Meanwhile, the television cameras were there, as you heard. It was the first presidential, and J.R. Jayawardena was there, and the whole cabinet was there. And these television cameras were trained on the commissioner. And of course, nothing was happening because he was waiting for his team. And the television continued, and the cabinet sat there in the town hall. Sam was just behind. And it went on and on and on. After just over an hour, the commissioner lost his nerve and said, "Professor Samaranayake, could you give me the results?" And Sam had scribbled them down on a bit of paper, which is highly unofficial, and handed them over to the commissioner. We knew that J.R. Jayawardena had just over 51%, and therefore there was no second round, and he was the president. And this was now read out. And a little bit later, he came to see Sam. He said, "I'm very relieved. 2 things. 1, I got the same result from down there, and 2, that took another hour and a half afterwards." And so a little known story about that first time. But we survived, and as you've heard, it's been used ever since. What about our Instat? Well, we now believe R is the future. And so we're now hard at work on what we call R Instat, with the same sort of objectives. And I just wonder whether here's one of the items where we could pick up our link and work together once again. We would find that very nice. We're 2 years into a project developing a front end to R to make it even easier, and also to help the climatic analyses be modernized so I can at last throw my old Instat away. I want to finish with 3 more topics. I've given you the first one. What now? Sadly, Sam has not been here for the last 10 years. I've picked out 3 topics from the last 10 years, and I wonder whether he would have jumped on this bandwagon. Maybe you have already. Maybe things would be different. So the first is computer-based maths. Each one of them has a TED talk. So This is a very stimulating talk by a man called Conrad Wolfram, who is the brother of Stephen Wolfram, who is Mathematica, saying we should teach children and university people real maths with computers. And his complaint is that currently, and it's the same in England or in the UK, we tend to teach calculating. We teach arithmetic and then algebra and then a bit of calculus, but we're teaching people how to calculate, all by hand. We should use the computer for all this, and then we can teach much more than calculating. And he makes a very persuasive argument. Of course, people have objections. One of the objections is you need to learn with paper first, and then you can move to the computer. And he gives a very nice argument about this. Here's his daughter, who's 8. And he says to his daughter has a hobby, which you sort of see here, which is she draws computers on pieces of paper. And he said to his daughter one day, you know, when I was your age, I didn't do that. I didn't draw computers on pieces of paper. Can you think why that is? And she thought for a minute, and then she said, no paper? And his point is that just because paper is invented before computers, once they're both around, does it matter which order they appeared in? Why does basic always mean you use the oldest one first? And there is certainly food for thought. However, before you jump on this bandwagon, you should look at his website, because it does seem to me it's an interesting example of a wonderful set of ideas that you could learn from, but putting it into operation seems harder in practice for him than giving a wonderful TED talk. So I wonder how much it's a bandwagon you should jump on. How much would Sam have jumped on that? This was 2010. In 2012, I think it's 2012, Daphne Koller from Stanford gave this wonderful lecture on MOOCs, where she discussed the fact that there was a class of 400 and they wanted to make it bigger, and it then became a MOOC, and it was opened up to everybody free of charge, and it was 100,000. And it was all free. In Reading University, we now produce MOOCs as part of a consortium. When we asked the people who were driving the MOOC production, and maybe you produce lots of MOOCs, when we asked Reading people why they're doing it, the answer was, it's better to be in than out, which didn't seem a very convincing answer. Before, if you're not spending lots of money in your wonderful new computer center producing MOOCs, you should also now look in 2016 at articles which discuss why MOOCs are dead. I don't think they're dead, especially if you look at some of the sets of these, but they're certainly not being treated in the same way as they were. It's difficult with computing. You've got to be careful which bandwagon you leap onto. But here's one I think that Sam would have taken, and this is what I'm finishing on. This is a very remarkable person called Neil Turok. He's a South African, but his parents, who, as you can see, are white, were evicted from South Africa because they were against apartheid in the 70s. So he grew up in Kenya and Tanzania, went off to Cambridge, and he's worried about the origins of the universe. And he's written lots of papers with Stephen Hawking, and he's now the director of the Perimeter Institute in Canada. But he never forgot his interest in Africa, and he has set up an inspirational MSc for African students doing mathematics. So they never have to go abroad to do their MSc. They can go abroad for their PhD, but they don't have to go abroad for their MSc. And it is a truly wonderful series of degrees. So TED, these series of TED Talks, they give prizes. And he won the TED Prize in 2008. And he used that to say, I don't want this one institute, which is regional, and you can see how many countries have benefited. I want to now have another one of these institutes. I want 15 of these. And so far he's got 6, and funding from all over the world, and producing 300 very interesting MSc graduates who have an inspirational course. I find it interesting that if you remember back to the past with Professor Samaranayake, he had many dimensions, and one of them was his trips to Trieste. He was also very interested in physics. So this combination of a theoretical physicist worrying about many practical things, here's another kindred spirit. I feel sure Sam may have met him, but if he didn't, he should have done. And I do think that this is an African success story that other places could learn from, and I think Sam would have done that. So finally, I'd very sincerely like to thank you for this opportunity to give this talk. I feel it's a wonderful way for me personally to pay just a little bit my respects to Professor Samaranayake. He was such a privilege to know as a colleague and a friend, and it's wonderful as I see here and everywhere just how well he's remembered by so many people. Thank you all very much.
The 10th oration, the 10th Vidya Jyoti Professor V.K. Samaranayake Memorial Oration, delivered by Emeritus Professor Roger Stern from the University of Reading, United Kingdom. Let's say a big thank you to Emeritus Professor Roger Stern. Thank you, sir. Thank you very much. And we have another spot of entertainment. So once again, we'd like to invite the students of the University of Visual Arts, Visual and Performing Arts for another dance performance. Ladies and gentlemen, we have a dance item coming up next.
It was in 1998 that the founding director of the University of Colombo School of Computing, late Vidya Jyoti, Professor V.K. Samaranayaka, initiated International Information Technology Conference, IITC. It was a forum for presentation of ideas and cutting-edge developments by researchers and academics in the field of computing. In 2010, IITC was renamed and relaunched as the International Conference on Advances in ICT for Emerging Regions. It was intended to obtain a wider international participation and promote research and development in computing in the emerging regions of the world, especially in Asia, Pacific, and Africa. With this relaunch, ICTA was able to attract the international recognition that was due and was able to emphasize the regional importance at this conference. Since the beginning, ICTA has been playing a pivotal role in creating a platform for computer scientists and academics to present their achievements and ideas while being subjected to a strict peer review. ICTA has been able to obtain IEEE technical co-sponsorship and indexing by IEEE Explore due to its maintenance of high quality. UCSC believes ICTA as one of its most significant annual events, considering its ability to promote research and disseminate knowledge in collaboration with other universities and industry locally and regionally. As a result, a significant number of academics worldwide and practitioners in the industry have joined with us by submitting and reviewing research papers, conduct workshops, as well as by contributing to organize the conference. In 2016, UCSC organized the 16th International Conference of ICTA in September at the Hotel Jetwin Blue, Negombo. It brought together nearly 200 local and international participants and 4 keynote speakers from 3 countries for 2 days of productive deliberations. It was held with Professor P.S.M. Gunaratna as the chief guest and Professor Mohan Munasinghe as the guest of honor. Every year, the selected best papers are published on a special issue of the sister journal ICTA, exposing quality work in an extended format. This year, ICTA is holding its 17th conference, having reached the significant milestone of Google's H5 median index ranking of 11, reflecting its quality as an attractive venue of publication and dissemination for researchers in the field of computing. It is time for the 17th International Conference on Advances in ICT for Emerging Regions, ICTA 2017.
That's the inauguration of the 17th ICTA. That's the inauguration. Come on, everybody. We made use of this platform and we made use of this opportunity for the inauguration of the 17th ICTA conference. And as you know, to be held on the 7th and 8th September this month. And that was the inaugural clip. And now we're going to have the inaugural address. And the inaugural address will be done by the chair of ICTA 2017, Dr. Noel Fernando. So we'd like to invite Dr. Noel Fernando for the inaugural address.
Professor Mohan D. Silva, Chairman, UGC, Your Grace, Reverend Dr. Oswald Gomes, Chancellor, University of Colombo, Senior Professor Lakshman Disanayaka, Vice Chancellor, University of Colombo, Professor K.P. Hewagamagi, Director, UCSC, our orator, Professor Roger Stern, and all keynote speakers and all deans, and other academics and other people from the university, students and ladies and gentlemen. As conference chair of the 17th International Conference of Advances in ICT for Emerging Regions, 2017, ICTA 2017. I have honor to welcome you on behalf of the ICTA 2017. It is a great pleasure for me to declare the opening ceremony of the ICTA 2017 and welcome the keynote speakers and participants from all over the world who came here to exchange experience and work together for a few days on the exciting field of computer science and information technology. We have the privilege of holding the conference in the beautifully furnished UCSC building complex and today open Vidya Jyoti Professor V.K. Samaranayak Auditorium. I wish to thank warmly initiated by the Professor V.K. Samaranayak, then Professor G.N. Vikramanayaka, and Professor Hewa Gammage, and Professor Lakshman Disanayaka, Vice Chancellor of the University of Colombo. Now I'll have to give a brief introduction about the conference. This is a unique opportunity to present the research and development activities in the computer science and ICT domain. The success of the seminal International Information Technology, IITC, held in Sri Lanka since 1998. This is technically co-sponsored by IEEE. This proceeding of the conference are published in book form and in the electronic format via internet and the DVD form. All presented papers and abstract will be substract to the IEEE Explore. The selected papers will be invited for publication in the special issue of the ICTA Journal. And conference will be held on 7th and 8th of the September, and pre and post workshops on 6th and 9th of the September. In this time, we received 135 full papers, and we did the review process by 3 or more local and international reviewers. In this time, paper and poster acceptance rate is 40%. I would like to give a brief introduction of our keynote speakers. Professor Marshall Bonach from Institute of Technical Informatics, Grace University of Technology, Austria. His title is Dependable Computing Platform for the Internet of Things. And Professor Abik Rochudel, ACM speaker, School of Computing, National University of Singapore. His title is Trustworthy Software and Automated Program Repair. And the next speaker, keynote speaker, Professor Kiyoshi Tanaka. He's from Faculty of Engineering, Shensei University, Japan. His title is Evaluationary Many Objective Optimization and Some Real-World Applications. And Professor Cripps from University of New South Wales and Sydney, Australia. His title is Accessing for Quality Decision Making. And Professor Rajasthan, his title is Climate Data Analytics for Agriculture. And final speaker, Professor Subramania from School of Engineering and Computing, National University of California. His title is Computational Science and Multidisciplinary Studies. And the workshops, regarding the workshops, today we had 2 workshops, software debugging and text analytics. And the 9th will be, there are 3 workshops, Internet of Things and e-assessment and algorithmic thinking for problem solving. In this conference, sponsors are completely organized by the University of Colombo School of Computing, technically co-sponsored by the IEEE, and our platinum sponsor is Cambio Software Engineering, and gold sponsor National Science Foundation, and silver sponsors are Millennium IT and IFS. Thank you very much.
So that's a gentleman who's vested with a huge responsibility as the chair of ICTA 2017, Dr. Noel Fernando. And finally, we have come to the vote of thanks. To deliver the vote of thanks, we'd like to invite the Deputy Director of the University of Colombo School of Computing, Dr. D.S. Athukorala.
Good afternoon. Chairman UGC, Professor Mohan De Silva, Chancellor, University of Colombo, Your Grace, Right Reverend Dr. Oswald Gomes, Vice Chancellor, University of Colombo, Senior Professor Lakshman Dissanayake, Director, UCSC, Professor K.P. Hevagamuge, all Deans and Directors of Institute of University of Colombo, Registrar and Bursar of University of Colombo, Emeritus Professor Roger Stern, Mrs. Samaranayake, invited guests, ladies and gentlemen. I am honored and privileged to propose a vote of thanks on this historic occasion to all those who have contributed in one way or the other to make this event a success. Let me express my sincere gratitude and appreciation to the chairman of UGC and the Chancellor and the Vice Chancellor of University of Colombo for gracing this occasion despite their busy schedules. A special thank to Professor Roger Stern, who accepted our invitation and traveled all the way from United Kingdom to deliver the 10th annual Vidya Jyoti, Professor V.K. Samaranayake Memorial Oration on the topic, A Glimpse to the History of Computing at University of Colombo. Professor Stern, you took all of us a journey through time in computing and statistics at University of Colombo. We were able to have such a fascinating speech at this state-of-the-art venue thanks to an untiring effort of one individual who is none other than Mr. S.T. Nandasara. I would like to take this opportunity to thank Mr. Nandasara for the services he has rendered to University of Colombo and UCSC over several decades. Further, we are grateful to Mrs. Samaranayake and the family members for being with us and helping us to make late Professor Samaranayake's dream a reality. I want to convey a note of thanks to each and every individual for their dedication and tremendous contribution in making this building complex a reality. In conclusion, I would like to express my sincere thanks to the director of UCSC and all the academic, administrative, and non-academic who worked hand in hand making this event a success. Thank you very much and have a nice evening.
Thank you very much. The Deputy Director of the UCSC, Dr. D.S. Athukorala. Now, ladies and gentlemen, I would like to draw your attention to three areas of interest right now. Firstly, we would be inviting all of you for a time of reception and fellowship. And the reception area is the same floor, level 4. And when you exit from the exit doors, the reception area or the refreshment area is right opposite on the same floor. So that's the reception area. And after the reception, we would be very warmly inviting you to take a few minutes and come to the first floor. Now, the first floor is an area where we have memories of the past. Past 50 years memories are, in fact, contained in the first floor. Then if you visit the second floor has some of the latest developments in computing research and development, as well as services offered by the different centers of the UCSC, and these are displayed in the second floor. Now, I'm sure that you won't be satisfied with the past and the present, and we see a very thirsty look in your faces as to the future. I'm sure you would like to know what the future is. And for the future, you need to visit or be a part of the ICTA conference. So thank you very much for your attention, ladies and gentlemen. We would like you to now enjoy a time of refreshments and fellowship. Thank you, and have a nice evening. Aiboan.
formal reasoning about software components. We will discuss the research on trustworthy software at NUS, which makes software vulnerability detection, localization, and patching much more systematic with the help of scalable semantic analysis. We will specifically explore research of futuristic programming environments which enable auto-patching of software vulnerabilities with a focus on automatic program repair, where software errors get detected and fixed continuously. Apart from reducing the burden on programming, this research aims to realize the vision of self-healing software for autonomous cyber-physical systems. Over to you, Professor Baig.
Come up. Should be on. It will be there. This one, right?
Thank you for the kind introduction, and I would also like to thank, maybe I should stand there because I need to use the mic. So I would also like to thank the University of Colombo School of Computing for giving me this opportunity to present course, being a semantic technique, this can be more inefficient. So I'll tell about some results just to show the application of these techniques in directed search in white box fuzzing. All of us might be familiar with pop-ups like this. We are trying to use a software, maybe the Adobe Reader, and it gives you a prompt like this, that it has encountered a problem and needs to close. Of course, it is sorry for the inconvenience. And then I don't know which one we usually click. So I usually click the don't send, but there are enough number of users who click the send error report. Okay, so it's not everybody is like me, silently accepting the crash, but a lot of people would send the error report. So once they send the error report, on the other side, it's not very easy to even reproduce the crash. Just to let you know about the challenges, it's not even very easy to reproduce the crash because the crashing input, in this case the PDF file in question, is not shared to the other side for privacy reasons. Okay, so it's not even very easy to reproduce the crash. So for in-house debugging and fixing, or even vulnerability checking, you need to reproduce the crash. You might only have the crash location and possibly a stack trace. So one of these works, it's just a sample. One of the works that we had looked into in this area is where you will take a program binary, possibly some information about the crash, say the crashing instruction, and some benign input files, which is always available. If you are trying to find out crashes in the PDF reader, you always have some PDF files. And from there, automatically generate a crashing input file, which specifically visits this crash instruction and reproduces that crash. So I'll not get into the details of all of the details of the technique that we had employed, but I'll mention some of the challenges. So for these kinds of problems on very large scale software, like software which we are regularly using even today, possibly as I'm talking, you are probably browsing some PDF files or looking at some videos, so things that we use regularly, there are many, many challenges for finding out vulnerabilities. And the least of which, the very first step, is to even reconstruct the control flow of the software. Whenever we have a certain program, if we can look at the source code of the program, we assume that regenerating the control flow is trivial. For these kinds of software, since you might just have the program binary, even regenerating the control flow is non-trivial, because the targets of a jump instruction could not be known at compile time. They could be given by the values of some registers, and that they may not be known at compile time. Okay? So this is certainly one challenge that we need to overcome, which we did. And then subsequently, even after these, actually this work was done on Windows binaries. So apart from the control flow graph, the Windows binaries would have modules. So we also have the module dependency graph, which is shown here rather cryptically as MDG. Once we have regenerated these structures which capture the control flow in the program, subsequently we do this task called this concolic exploration, which is essentially the symbolic execution approach that I showed just now, where you try to cover more and more paths in the program in a systematic fashion. But then you don't want to make, the trick of the trade is you don't want to make everything symbolic. Imagine that you have a PDF file, a PDF format. You really cannot afford to make every field in the PDF file symbolic, because you would just have too many symbolic variables, and the vulnerability detection will be very, very inefficient. So we try to also find out through this taint tracking which ones should be examined further, and then subsequently we go into the crash location and generate a crash revealing input. This one single flow, this involves many, many heuristics, how to even do the backtracking, even after you have decided on the symbolic variables, how to even do the backtracking. There are many, many nifty heuristics, how to handle string variables, because the string variables create a very large search space, and so on. So I'll share some of the results. So you can see these are really experiments on real-life software at a very large scale. Even if you can reproduce the crashes within 24 hours, that's considered a fairly big win. And here, this is the technique that we had developed, the tool. This is actually a commercial, so people would pay a lot of money for this kind of a commercial fuzzer, a commercial black box fuzzer. And this is a purely white box fuzzer developed at EPFL. This is the version that we had at that point of time in 2015. These are all the programs that we tried out on. This is actually the Windows Media Player, the Acrobat Reader, Real-Time Player, Orbital Viewer, and so on. So you can see the results. I'll not dwell too much on the results, but this is just to show the kind of capabilities that are possible. I'll mention briefly about the vulnerabilities in file processing programs. This is an area that is quite actively looked into by the companies. Because there are lots of vulnerabilities. So this is actually showing the number of CVEs that are lodged. Every vulnerability that exists, there may not be a CVE in the US National Vulnerability Database. So you can see this is fairly large. I have the slightly older figure. I should update it with the 2017. And these are all the usual formats. So the combination that we had worked out here, I'll not again get into all of the details of the techniques. The combination that we had worked out here is that we have again a test suite. So if we are working with a PDF reader, this could be a bunch of PDF files. So through a file cracker, we will try to crack open the various fields in the file. And then we have a pool of fragments to play with. And then subsequently, we will be doing symbolic execution, but as we do the symbolic execution, it finds out what are the important fields that are required for reproducing crashes that are not even present in the existing seed files, because the symbolic execution might get stuck. And this is what we call as the crucial if statements, where we cannot make any further progress through the semantic analysis, and then we come to the syntactic analysis, let it come to our rescue. So this file stitcher really comes to know from the symbolic execution what are the fields that are missing, and it generates an appropriate mutation, which is then given as the seed to the symbolic execution. So this is a kind of a nifty combination that we had looked into. This one led to much better results, I would say. Again, these are all fairly well-known programs like the VLC player we would be familiar with, again the Windows Media Player, Acrobat Reader, and so on. So this one we call as just the ++. The previous tool was called Hercules because it's a Herculean effort to analyze these kinds of software. So this one we just call as ++ with this kind of an addition. So this probably gives a flavor of some of the capabilities that can be that we have tried to build in the area of vulnerability detection. Now I will switch gears a little bit and talk about one specific vulnerability detection technique that we developed. It was built on top of a very popular fuzzer which is used very widely called the AFL fuzzer. AFL stands for American Fuzzy Lop. So what we did is we just made a very small change, a very small change. The total amount of coding done by us was probably less than 30 lines of code. A very small change in it, and kept everything else the same, and increased its effectiveness by more than an order of magnitude in terms of finding crashes, at least as witnessed by the DARPA Cyber Grand Challenge binaries that I mentioned earlier. Okay. So just to recap, this technique takes in a test suite. Again, there's some seed inputs if we are trying to crash the PDF reader, PDF files. And it has mutators which will generate the mutated files. And then from there, it will try to choose certain interesting inputs for further examination. So just to make it, just to show this in the fullest details, it's not very complex. The overall algorithmic framework for finding these crashes is not very complex. I can fit this into half a slide, okay? So here we are really having these seed inputs S. We start with those. And the TX, this is really the set of crashing inputs that we are trying to find. So really the only knobs that you have, the only knobs that you can tune is that once you choose an input for examination, how much time you will spend on examining it. And whether you choose, once you choose an input, whether it is deemed as interesting for further examination. So the only change we made is just in this, that once an input is chosen, how much time we will spend on examining it. And it so turns out that in the CGC binaries, they produce the crashes more than an order of magnitude faster. So that's able to get into all of the details of what made it faster, but I'll give the general intuition. Oftentimes, when we are programming, if we are a good programmer, and of course we are all talking of commercial software here, so these are well-written software. If we are a good programmer, we would have lots of checks at the beginning, like if checksum is not valid, then quit, then abort, or if this other length field doesn't meet this constraint, then you get out, and so on. So you would have lots of checks, and so there will be some very shallow logic at the beginning of the program leading to some very short paths which are exercised by invalid inputs. Okay? So therefore, if you have a semi-random procedure of just mutating a PDF file, generate another PDF file, you would generate a lot of invalid PDF files which just go through the same shallow logic, and it's not at all exploring the deep logic in the program where there would be more interesting and nifty vulnerabilities. Okay? So we try to avoid going through these short paths again and again and again by changing this assign energy function. So this is the only change we made. This was the key observation, and the results are there to see. This was published in this last year's CCS, and the results are there to see. So here you can see this is without the change. This is the normal American fuzzy lob, which a lot of companies also, there are a lot of company users of this. And this is the number of test cases plotted against the number of paths that are traversed. So this is a graph in the log scale, and I don't know whether it's visible. There are 3 dots over here. So 3 of the paths are being traversed at least half the time. Half of the time budget is going away. And here you can see double as many paths are being traversed, could be even more, and typically in much less time. Of course, it's always good to have results in academic papers, but to me what was very, very pleasant is that we also got very good online reputation, and as soon as we put up the results, there was a lot of acceptability of it, as a result of which it was integrated into the AFL name rank so that this technology is available. Right, we have also looked into other kinds of, this is the latest results just from this year in CCS, where we have tried to bring in the power of semantic analysis. This gray box fuzzing, it's really not a semantic analysis. It's really following a genetic algorithm kind of approach, which has an inherent amount of randomness in it. Randomness is also useful for getting out of certain regions in your program. If you get stuck in semantic analysis, randomness is useful for getting out of there. But we need to combine the power of semantic analysis as well as these kind of random and semi-random approaches. This is what we have done in the latest results, where we want to take the key power of semantic analysis. The key power is that it is directed. If I tell that reach this location in the program, that can be stated as a constraint, and the constraint solver can take care of it. So we want to bring in this key power of semantic analysis into these kind of random and semi-random approaches so that the technique is both effective and efficient. So these are the latest results we have, and in fact we have this has been integrated already. In fact, the conference hasn't taken place yet. The results have been integrated already into this OSS fuzz. And this has a variety of applications. Of course, we would be interested, rightly so, in the applications. So for example, when you introduce patches, you want to test them. If this was done properly, the Heartbleed vulnerability would never have been introduced. Okay? This is what we showed in our work: reaching a dangerous location, crash reproduction, and so on. Okay. So in the remaining time that I have, I'll talk a little bit about this auto-patching work. This is another capability building that we are trying to do at NUS, and this is also in this area of software engineering and software security. This is also at this point of time a very hot area. So if any student here is looking for a suitable research area to look into, this is a good hot area to get into at the right time. Okay. The problem here is extremely simple. We have a buggy program, and we have some correctness criteria given in the form of failing or passing tests, and we want to produce a minimal modification of the buggy program so that it can pass these tests. Okay? So this is really the dream that we would like to achieve, and only if we achieve this dream is the dream of automatic programming ever possible? Because of course, if we cannot even patch our programs automatically, there's really no possibility of programming automatically. So we try to divide this problem into 3 steps: where to fix, what to fix, and how to fix, as was mentioned in the video. And for some of these techniques, we are trying to use this symbolic execution. I'll just mention the key intuition and how it differs from previous genetic approaches. There were other approaches like called GenProg, which focuses on genetic programming. So given a buggy program, it will go through generations, try to generate mutations, and try to see whether they are passing enough number of tests, and this process will go on until you hit a program which passes all the tests. Of course, this process can take quite long, and you may not get a repaired program. So in our approach, this is what we did. We tried to divide the task into these 3 steps: where to fix, the fault localization, the specification inference, and the patch synthesis. I'll not get into all of the details, but I'll just give the key intuition via one simple example. Assume that this is the program we are trying to fix. The error here is this bias equal to downsep. This is mistaken, and it should be bias equal to upsep plus 100. How can your programming environment figure this out automatically, provided you are given a set of test cases which capture your intention in the program? So maybe some of these test cases fail, and you want to make the small change in this program so that all of these test cases pass. The interesting thing to notice here is the first step is debugging, of course, where to fix, and there may be choices. But even if we know, suppose even if in our dream we came to know, somebody came in our dream and told us in our years that line 4 is the one you need to fix. Even then, the programming environment cannot figure out automatically, because there are infinitely many expressions with which it can replace it, or even the left-hand side may be wrong, and so on. So there are infinitely many ways of mutating this, and if we just go through them one by one, this may not be a very productive endeavor. So the key intuition of what we have done, so first is of course the localization. Even if we know it is line 4, there are some techniques for that. The key intuition that we have done is that we say that, okay, this will be an expression, and I don't know what expression it will be. Let's call it x. So we just replace it with bias equal to x. And for the different test cases that are failing as well as passing, we do concretely execute it up to that point and try to see what values x should take so that the execution then leads to a passing execution. So for example, here, through an analysis of the program, I can figure out that if I go down this path, I will pass the test, but if I go down this path, I will not pass the test. So the key intuition is really this task of automatic program repair. We are converting it into synthesis of a mathematical function. So we say that this can be any function here, this expression on the right-hand side, this can be any function here. And we just call it a function f in terms of the live variables of the program. In this case, these are the only live variables. So we just say that now I have to synthesize a mathematical function, but it should be such a mathematical function that it passes all my tests. And now I can gather properties about this mathematical function by running each of the tests. So I run this test, which was failing, it comes up to here, and then I come to know that, well, from this x greater than equal to 110, this x is not any x, but it is a function of the live variable. So I come to know a small amount of property. So this is a pure intuition here. We come to know a small amount of property about this mathematical function that I need to synthesize. And from each of the tests, typically in an industrial scale software, you have a fairly rich test suite. From each of these tests, I can get small properties like this about the mathematical function that I want to synthesize. And then, depending on the components, that is the operators that can appear in the function that I want to synthesize, I can actually generate the expression. So the key intuition here, there are a number of works that we have done here. And subsequently, we have also developed some technologies which are publicly available. But the key intuition here is this task of automatically fixing your errors. This can be converted into synthesizing a mathematical function. And then from the test cases in your program, you gain properties about this mathematical function. So this was the key observation, and subsequently it has been taken up by a number of research groups. It also leads to, I will not get into all of the details, but it also leads to higher quality patches than the syntactic analysis approaches as might be expected. And it also helps in terms of this so-called overfitting problem in program repair, because the correctness criteria is just given by test cases, which is an incomplete specification. So it can overfit the test data, so it also helps in that regard. So with that intuition, I'll probably conclude this part. In fact, this is not the latest results. I put this in quote because I didn't update the slides. So this is just the results from the Heartbleed vulnerability. So you can see this was just the vulnerability. This is the buggy part of the OpenSSL library. The only thing that caused the vulnerability is that this check was missing on the payload. The payload may be too long, and it should check whether the payload is too long. So this is the fix that is generated automatically, and this is the developer fix, where it is checking whether payload plus 19 is greater than this expression, and the fix that is generated automatically is payload plus 18 is less than. So actually, the automatic system is generating a fix which is not identical, but it is functionally equivalent to the human fix. And this is the direction we are going towards. Again, I'll not share all of the results, but this is just a sample of the capability. Okay. We also have subsequently taken this work forward in the form of a spin-off from NUS, which does this kind of fuzz testing on mobile apps, where we have also an automated model extraction from the mobile app, the Android app, and from there do automated test generation. Not only for crashes, but also combining it with manual testing, because whenever we launch a spin-off, we have to cater to number of clients. So sometimes the clients might say, we have fair amount of testing done already. Can you help improve it? Rather than trying to do everything automatically. Okay. So just to bring this part to a conclusion, so we have looked into this scalable analysis on program binaries. There are a variety of techniques, a variety of observations going into it, clustering of paths, controlling symbolic variables, and so on. And there are a variety of users. So for example, there is interest from anybody working with safety critical software. Before they procure some software, they want to run these kinds of checks on the, say, on the evaluation version, because this can be run directly on the binaries. Or people trying to do a COT system assembly. So we are working with number of organizations into transplanting some of these techniques. And one of the key observations that we had here is that apart from guiding the search, this is also a process for extracting the semantics, the intended behavior from buggy programs. Okay. More details are available from these websites. So I will very quickly mention this Singapore Cybersecurity Consortium. In conclusion, this is a consortium of 25 member companies that we have set up, that I helped set up about a year ago. This is a very good engagement platform for companies, academia, government agencies, our National Research Foundation, and also a lot of students. And that is one thing I want to talk about. So the consortium has a number of activities in training. So there is a training camp. This might be of interest to some students here. So that's why I wanted to talk about it. Also a forum, providing a forum for engagement like tech updates, a wacky day, wacky styles for wild and crazy ideas, as well as translation. So providing seed grants and creating a repository of projects, because the professors might be too busy. There might be many, many student projects which are ripe for translation, and they could be made available to the companies. So this is an endeavor that we have taken up in Singapore. There are quarterly tech update meetings. Of course, management of the intellectual property, that is a key issue, and lightning sessions and so on. One of the goals is to promote greater translation, use the repository of projects that already exist in the institutions of higher learning, IHL, and therefore provide a pathway to the companies from training to alleviate the pain points, and then finally in terms of research collaboration. And for this reason, we also give out seed grants for company-university pairs. So the consortium gives out seed grants for company-university pairs to team up and do projects. And we are also having these special interest groups so that there are more targeted discussions on threat intelligence, data protection, mobile security, software security, IoT security, and finally cybercrime. Each of these this is a Singapore-wide effort, not only in NUS. So each of these special interest groups is headed by a separate entity, typically a university. It could also be a research organization, or in the case of cybercrime, could be the government or a government ministry. So specifically, I wanted to talk about the cybersecurity camp that we hold every year. This year, it will be on artificial intelligence and security, and it will be coordinated by Don Song from UC Berkeley. So the students here, if they are interested, there is an application process, and feel free to apply. And we try to provide some scholarships to interested students for attending this camp annually. Okay. With this, I would like to conclude. Thank you very much once again for giving me this opportunity to share the developments, and congratulations once again on the new building and the new auditorium. Thank you.
Please don't go far, just stay. Thank you very much, Professor, for that very mind-blowing session. Now, it's a special moment to felicitate Professor Abik. May I now invite Professor K.P. Hewagamage, the Director of UCSA. Thank you very much, both professors. Now, before we break for tea, we have all of you, I want you to stay because we have to take a group photograph. And before that, there's a little message that I would like to convey. That is, we would not have had this event without the help of these people. That is technical sponsor, IEEE, our platinum sponsor, Cambio, gold sponsor, National Science Foundation, and the silver sponsors, Millennium IT and IFS. Now we have a message, a brief message from our sponsors. Yes, thank you very much. And before we break for tea, I would like to announce where we would have the sessions. The session on software engineering will be held at the mini auditorium, second floor. And the session on language processing will be held at the ADMTZ, that is on the third floor. And the session on ICT for development will be here. So those who would participate for that session on ICT development, ICT for development, can stay here after tea. Now, before we break for tea, I want all the registered members as well as the keynote speakers on stage, please. So can we have all the keynote speakers and the registered members of the ICT conference here? The UCSC staff and the members of the review panel as well. Please come. All the members of the organizing committee and all the authors are invited as well. Reviewers, so I'm sure you do not want to delay your refreshments, so please come over. It doesn't matter whether you're photogenic or not. Please come. So thank you very much. I would like to once again announce the session as you break for tea. Session 1A, that is software engineering, will be at the mini auditorium. And session 1B will be there at the ADMTC, third floor, language processing. That's the session. Session 1C on ICT for development will be held at the VKS auditorium, that is here. And please be back by sharp, the sessions will start sharp at 11. Thank you very much.
So meanwhile, I would like to give some few announcements as well. The tea will be served in the 5th floor, which means that one level up in the 5th floor. At the same time, the premise is Wi-Fi enabled. SSID is ICTR 2017. So you may mind the password. All letters are simple. ICTR 17 at UCSC. ICTR 17 at UCSC. SSID is ICTR 2017. Right. Thank you.
into a deterioration in other objectives. This set of solutions is known as Pareto optimal set. Here I explain the definition of dominance and Pareto optimal solutions. First, solution X dominates solution Y. Because if X is better or equal than Y in all objectives. So in this case, in the case of F1 and F2, X is superior than Y. And X is better than Y in at least one objective. For example, in this figure, solution X has better fitness value than Y in both objectives. Next, Pareto optimum solutions, POS, are all solutions which are not dominated by any other solutions. In this figure, this one and this one, this one. So these three solutions are POS since they are non-dominated solutions. A multi-objective evolution algorithm, MOEA, starts usually with an initial random population and evolves these solutions to find a good approximation of the Pareto optimal set in a single run of the algorithm. The goodness of the approximation is measured in terms of its convergence, spread, and diversity of the solutions. MOEAs are effective for convex, concave, and discontinuous Pareto front. The role of the MOEA to find a representative set of trade-off solutions. Since usually there are many trade-off solutions, it is important to analyze them and then follow a decision-making procedure to suggest few solutions for possible implementation. This block diagram illustrates the main steps in a MOEA. So first, step one. First, the MOEA creates an initial population of candidate solutions. The initial solutions are usually created at random. Step two, then these solutions are evaluated using the multiple objective functions. Step three, selection ranks solutions and probabilistically chooses with more frequently those with better rank to create new solutions. The offspring population is created using operators of variation known as recombination and mutation. The population for the next generation is formed by combining the current population with the offspring population and selecting the best form of them. This process is repeated a number of iterations. Solutions improve from generation to generation until a set with good properties of convergence, spread, and diversity. Next one. So we call evolutionary many objective optimization instead of multi-objective optimization when the number of objectives to optimize is more than 3. This distinction is historical, and it is meant to emphasize scalability issues related to the algorithm when the dimension of the objective space increases. When we increase the number of objective functions used to evaluate solutions, the number of optimal solutions increases significantly. Usually, the number of optimal solutions increases exponentially with the number of objectives. Of course, this has several implications on the behavior and performance of the algorithms. To have a better idea about many objective optimization, we can look into the effect of changing the number of objective M on the number of solutions and fronts. This figure plots the average number of solutions per front for MNK landscapes, so multi-objective NK landscape problems with objective number is 2, 3, and 5 objectives. And the total bit number optimized is n equal 20 bits, and epistatic interactions Ki is 0, 3, and 10. Note that the number of solutions increases in one order of magnitudes, varying the number of objectives from 2 to 3. And also another one order of magnitude from 3 to 5 for all value of epistatic interactions. Conversely, the number of front decreases in one order of magnitude from 2 to 3, and in another order, one order of magnitude from 3 to 5 objectives. Similar trends are obtained for landscapes with different number of bits n. Here, important questions emerge regarding the implication of this increased number of solutions in the selection procedures. Selection procedure means parent selection, truncation of survival selection that operate in objective space, and the variation operators, which is recombination and mutation that operate in decision space, decision and variable space. Another way to understand the implication of a large number of non-dominated solutions is to look at dynamics of the algorithm. These figures illustrate the number of non-dominated solutions over the generations. Number of solutions and number of non-dominated solutions over the generation after combining the current population and the offspring population. Results are shown for 2, 3, and 4 objectives on 3 well-known DTLZ benchmark problems. These results are for a class of MOEA that ranks solutions based on Pareto dominance. The horizontal line of this graph illustrates the size of the current population. Note from the figure that the number of non-dominated solutions increases as generation pass by. So if we increase the generation, the number of non-dominated solutions increase. Also note that for some problems, the increase of non-dominated solutions happens earlier and larger as we increase the number of objectives. Also note that for some problems, the number of non-dominated solutions becomes larger than the size of the population. This is the line of the size of the population. So we can say that this kind of algorithm undergo 2 stages during the search. A first stage in which the number of non-dominated solutions is smaller than the population size. This period. And the second stage in which the number of non-dominated solutions is larger than the population size, from here. This has strong reason in the selection of solutions. Basically, non-dominated solutions in dominance-based MOEA are ranked equally. Few non-dominated solutions in the population imply that there are several fronts in the population with a diversity of ranks. That selection can use to discriminate between solutions. However, if the number of non-dominated solutions is larger than the population size, all solutions in the surviving population have the same rank. In other words, selection becomes random because it cannot discriminate between equally ranked solutions. This significantly affects search performance. This phenomenon is one of the major issues we find in many objective optimization. It also shows that the transition towards a state where all solutions become non-dominated in the population also happened. at some point in 2 and 3 objective problems. Thus, the same performance problems observed in many objective optimization are also expected in multi-objective optimization after some generation. Historically, algorithms were designed for 2 or 3 objective problems, and there are a number of algorithms are quite effective. However, traditional MOEAs do not scale up well on many objective problems. An important activity in our lab is to understand the reason for this lack of scalability and find ways to develop effective algorithms for many objective optimization. Research in many objective optimization is a hot topic. There are various approaches to tackle many objective optimization. The most important ones are listed here. Parade dominance extensions and decomposition-based and performance indicators. The most common approach that being pursued to develop algorithms capable of searching on high-dimensional objective spaces. Dimensionality detection aims to analyze the correlation between objectives in order to reduce the dimensionality of the objective space by keeping only the objectives that have trade-off with other objectives. Preference refers to the inclusion of user preference to reduce the search or objective space. Space partition aims to find optimal solutions in the original high-dimensional space by instantaneously searching in several lower-dimensional subspaces. This is a list of some of the algorithms used for multi and many objective optimization based on 3 main approaches used to develop algorithms. The algorithms in blue show that those algorithms specially developed for many objective optimization. In the following slide, we will explain a representative algorithm for each one of these approaches. First, I will explain the main concept behind decomposition-based algorithm. The decomposition algorithm decomposes the multi-objective problem into many single objective optimization problems. This is achieved by using a set of weights. In this case, 2-dimensional, but all the vectors is set of weights. This achieved by using a set of weights that determine different size direction in the original objective space. A solution is associated to each such direction. At the beginning, this solution is usually created at random. The algorithm determines in advance a neighborhood around each such direction. Parents are selected from the neighborhood in order to create one offspring. Once the offspring is evaluated, it is compared with the solutions in the neighborhood. If the offspring is better than the neighbors, it replaces them. Then it continues with the next search direction, performing parent selection and replacement within the neighborhood, associated to the current search direction. Once parent selection and replacement for all such directions have been done, the algorithm repeats several iterations to find good approximation of the Pare's optimal set. An indicator-based algorithm uses a function to assign a scalar to a set of solutions. The rank of solution X is determined from the scalar difference of the values assigned to the set S and the set without the solution X. As well-known algorithm from the indicators-based approach is SMSMOEA. This algorithm uses the hypervolume as indicator. It joins the current population with the offspring and divides the joint population in front. The solutions with less contribution to the hypervolume are eliminated one by one until we reach the number of desired solutions. A representative of the extensions of Pareto dominance approach is an adaptive epsilon sampling and epsilon foot merge of MOEA algorithm, AESEH algorithm. This algorithm uses epsilon dominance principle for survival selection. In addition, it applies epsilon dominance to create neighborhood in objective space and restricts the recombination to solutions within the same neighborhood. Okay, yes. This slide illustrates the use of epsilon dominance to select a subset of non-dominated solutions for the next generation. The algorithm selects randomly one non-dominated solution, this one, expands the dominance region of the solution by using the epsilon, based on the mapping function that uses epsilon as a parameter and applies epsilon dominance. Solutions epsilon dominated are not considered for the next generation, these ones. This procedure is repeated with the remaining solutions until none is left. If the number of sample solutions is larger than the population size, the required number is discarded randomly. On the other hand, if the number of sample solutions is smaller than the population size, the required number is copied to the population from the epsilon dominated solutions. The value of epsilon is key factor in this algorithm to induce set of sample solutions, which size approaches the size of the population. AESEH uses an adaptive procedure to appropriately set the value of epsilon at each generation. Next one. Epsilon dominance is also used to create neighborhood of solutions. In this case, epsilon dominated solutions are used for the neighborhood of the sample solutions. To create solution, parents are selected within the same neighborhood. Here, epsilon is also adapted at every generation.